And welcome to a new problem solving session. We are still considering problems on electrostatics. And perhaps in this problem, we need to find out the pressure on the surface of a sphere, of course, due to the interaction of charges. And if we can read the statement of the problem, it says simply that we have a conducting sphere of radius r, has a charge q, and we need to determine the pressure on the surface of the sphere due to interaction of charges I was talking earlier. And of course you can simply write the surface density of charges on the sphere, denoting it by sigma or something like that. And you can write it the total charge on the surface of the sphere, because surface is a conductor, divided by its surface area, that is 4 pi r square. And if you want, you can also find the electric field at a point on the surface of the sphere or just outside it, at a very small distance from the surface. You can write the electric field simply as 1 upon 4 pi epsilon naught q by r square, and that is nothing but sigma by epsilon naught. You can see here. And we need to solve this problem. And to solve this problem, I would like to select a small element of area ds on the surface of the sphere itself. Or you can say I need to select a patch, very small patch having area, having surface area ds. And I would like to the electric field produced by this small patch. I would like to compare the electric field produced by this small patch of area and overall the sphere itself. So we have an information that the electric field just outside, or you can practically say at the point itself, the electric field is simply in a direction radial to the sphere, and this electric field is nothing but sigma by epsilon naught. And if you want to consider the patch here, this patch, this small patch, this point is too close to it, and it can be considered as an infinite plane for this point. And at this point, this a small patch will produce an electric field that value will, you would like to write it E dash, and that will be nothing but sigma by 2 epsilon naught. And at a point, what about a point just inside and near the patch? The net electric field is 0, of course. And the net electric field is 0 inside the sphere at any point inside the sphere, so it will be 0 at a point very close to the patch itself. And this will be constituted by two electric fields, namely the electric field produced by the patch and the electric field produced by the rest of the sphere. And I would like to write it as this 0 is equal to electric field produced by the patch plus electric field produced by the rest of the sphere. And so it is obvious that the electric field produced by patch will be equal in magnitude and opposite to the direction of the electric field produced by the rest of the sphere at this point, at this particular point. The vector equation says many things. One of the things is that since the net electric field is 0, so both these electric fields, the electric field produced by the patch and the electric field produced by the rest of the sphere, should have equal magnitude and opposite directions. So I'm considering about magnitudes, and I can write here that these two things are same. and their value is of course going to be the electric field produced by the patch, and this is nothing but sigma by 2 epsilon naught. Yes, so the rest of the sphere and the patch itself both are producing same electric field, but in opposite direction at a point inside the sphere, near the patch of course. And now we would like to write the expression for force acting on the charge of this patch from other charges on the sphere. And of course this small patch will have the charge dq, something dq, and it would be like sigma ds, because charge, this surface charge density is sigma, and ds is its surface area of the patch, and the force exerted by the other charges on the sphere on this charge dq can be written as df, and df is the electric field produced by rest of the charges multiplied by dq by definition simply. And this E rest has got the magnitude equal to the E patch, and that is sigma by 2 epsilon naught. So df can be written as sigma by 2 epsilon naught multiplied by sigma ds, the charge on the patch. And we can write one more line or one more equation here, like this has become sigma square by 2 epsilon naught ds, and we need to simply integrate it, or if you find the pressure on the surface of the sphere, if I denote pressure simply by P, the pressure is force per unit area, so we can also write it simply the pressure as df by ds, and we can directly get the value of df by ds from here, and from this equation, and that will be sigma square by 2 epsilon naught. Or if you want to convert in terms of q, you will get q square by 32 epsilon naught pi square r raised to 4, and this is the pressure, and its value is sigma square by 2 epsilon naught, the pressure on the surface of the sphere due to the interaction of charges. And this is it. Thank you very much for watching.